This tape is on the circle. Now I want to deal with just many examples as I have time for on the tape, and kind of as I work examples do some discussion about the concept, but mostly this will just be example problems. Let's look then at the first thing about circle. We have the general form equation of a circle that says we have x minus h parenthesis squared plus y minus k parenthesis squared is equal to r squared, where this number over here that's squared is the radius of that circle, and whatever these numbers are, this h and k, is the center of that circle. Looking at the graph there, this h and k is the x and y value of the center of the circle, where this number over here squared happens to be the radius of that circle. Now this comes from the definition that a circle is all points are the same distance away, and so you let this distance, the square root of x minus h squared plus y minus k squared, all that's distance, is equal to the radius, that distance r, whatever that r is. And you square both sides, you get rid of the square root sign, you get r squared, and that's the definition of a circle. All points are the same distance away from a fixed point. The fixed point is the hk. The distance away is the r. So we get then this form for the equation for a circle. Now what you've got to memorize is just that, where h is the x value of the center, k is the y value of the center, r is the radius of the circle. All right, let's look at the first example. Example 1, we have the graph of x minus 3 in parentheses squared plus y plus 2 in parentheses squared is equal to 16. All right, the center is at 3 minus 2. Minus 2. Now go back and look at the formula for the circle. It is x minus y minus. That means, back over here now, then if we have y plus 2, that must have been y minus a minus 2. Now, however you want to memorize it, it's the opposite sign. If this is a minus 3 here, it's a plus 3. If it's a plus 2, it's a minus 2. Whichever way you want to memorize it, it's fine with me. As long as you get down, the center of this circle is at 3 minus 2. So we'll come over here 3 units and down 2 units. And we have the center of the circle. The radius must be 4, because you remember the formula is r squared, not just 16, but it's always the square root of that number. So the radius is 4. Now this was down here at 3 minus 2. So if I come up here 4, if I go over here 4, go down 4, and over here 4, then I get the circle whose center is at 3, 2, and whose radius is 4. Okay, that's all there is to graphing. Let's look at an extra problem that's not in your notes. What happens if we have x squared plus y squared is equal to 16? Well, what this really is the parenthesis x minus 0 squared and y minus 0. Which is simply saying is if you don't have that in there, then the center is the origin and a radius of 4. So we'll come out here 4 and around 4. And we have the circle whose center is 0, 0, and whose radius is 4. Now that's it. As far as the concept of a circle and graphing it, this is it. If you look at both of these examples, example 1 and the extra one I have on the board here, it's simply saying that if you just have x squared plus y squared equals something, you have a circle whose center is at, in this case, 0, 0. In this case, 3 minus 2. If you have x squared plus y squared, you have a circle whose center is at whatever this is, whatever this is. And that's it. All right, let's go to some more examples of this. Looking at your notes, example 2 says this: write the equation of the circle such that the line segment joining these 2 points, 5 minus 1 and minus 7 minus 5, is the diameter of the circle that goes through those 2 points. We have a circle that goes through these 2 points. This is its diameter. Now, to write the equation of a circle, I need the center and the radius. I need the center and the radius. Well, where's the center? Well, if this is the diameter, then the center of the circle is the midpoint of that diameter. What is the midpoint of that diameter? Well, we go back to the median of a line. It's x plus the x divided by 2. 5 plus a minus 7 is a minus 2 divided by 2 is a minus 1. So over here at minus 1, minus 1 added to a minus 5 is minus 6 divided by 2 is a minus 3. So there's our center. Now all we got to do is come up and fill that in. Minus 1 for x, so this is a minus 1. Minus 3 for y, minus a minus 3. Now, what's the radius? Well, the radius is the distance from here to here. Distance formula. That's the square root of, all right, minus 1 minus a minus 3. I'll just write it, minus a minus 3 squared. 5 minus a minus 1 squared. And so we have the square root of, this would be 2 squared, which would be 4. This would be 6 squared, which would be 36. The square root of 40. The square root of 40 is the radius. So that squared is the equation. And there's the equation. X plus 1 squared plus y plus 3 squared is equal to the square root of 40 squared, which is, in this case, just equal to 40. So the equation of this line is x plus 1 squared plus y plus 3 squared is equal to 40. It is the equation of the circle that has a diameter at the points minus 7 minus 5 and 5 minus 1. All right, let's look now at example 3. Example 3 says this: a circle is tangent to the line 3x minus 4y equals 32. Now let's look at the figure just for a moment, then we won't have to look at it anymore. What we're saying is we have the line 3x minus 4y equals 32, and we have a point out here which is the center of the circle, 0, 7. And we want to find the equation of that circle where this is its center and it's tangent to this. Now, if it's tangent to that, that means the line drawn from the center to the point of tangency is perpendicular. All right, now, to write the equation of a circle, look back now at your notes. To write the equation of a circle, it is x minus the center. Well, the center is x is 0. Y minus the center, y is 7, is equal to the radius squared. All right, we've got to go find the radius. Now, I hope you start seeing the point of this. To write these equations, you must find center and radius. Well, they gave us the center. We've got to find the radius. How far is it from the center out to that point of tangency? Well, that happens to be the distance formula. the ax1 plus by1 plus c over plus or minus the square root of a squared plus b squared. You see, to find that distance from the center out to this line, the distance from the center to the line, it's the distance from a point to a line. All right? So the line is 3x, so that'll be 3 times. The point is 0. Minus 4, the point is 7. Minus 32 over minus the square root of 3 squared plus 4 squared. That's the a, b, and c of the equation. 3x minus 4y minus 32 is equal to 0. Put the a's and the b's down here. Since this is negative, this makes this negative. In working that out, we get a minus 28 and a minus 32, which is a minus 60, divided by minus 5, which is 12. And so the radius is 12 squared. And as you notice, your equation then becomes this. Now, that's all there is to working with given, something where we can find the center of the radius. That's all there is to finding the equation of the circle. Now, we've got to do one other thing in this, though. The back of the book usually doesn't leave it like this. What they do is go ahead and square all this mess out. This would be x squared plus y squared minus 14y plus 49 is equal to 144. So that's x squared plus y squared minus 14y minus, 95 is equal to 0. And there is kind of the answer they'll have in the back of the book. Well, now there's an important concept in this. What we're going to do now, in the next few examples, is go backwards. So what if they give you this equation and tell you to graph it? What if they give you this equation and tell you to graph it? What we must learn to do then is to take this and go backwards till we get this form. And once we get this form, then we can say, hey, the center is at 0, 7. It has a radius of 12, and we can go graph it. Okay. First, and all this is going to be is algebra that we're going to have to review and show you how to do it. But what I'm trying to tell you is this. 2 things basically about a circle you need to know. Number 1, if you're given some things, come up with the equation by knowing this is the center, this is the radius, and then graph it. Number 2, given the equation in an expanded form, being able to bring it back to this form so that you can see center, radius, and graph it. All right, now let's look at example 4. Example 4 says, graph this equation. It's got an x squared and a y squared and a bunch of x, y's, and numbers. So, looks like it'll be a circle. Let's just see. Now, you pay attention to all the algebras involved. Usually this is where you'll be stumbling around. What we will do first step is group the x's together. And I'm going to leave a space right there, and then I'm going to group the y's. And I'm going to leave a space here, and then I'm going to move the constants to the other side. Now, what I want to do is to what's called complete the square. I want to add a number here such that I can come back and get this factored into a parenthesis, factored into a parenthesis is equal to something over here. And if I do that, I have a circle. X minus or plus something squared, y minus or plus something squared is equal to a number. That's a circle. So what we need to do then is to add something here and here. Now remember, if I add anything, I've got to add it to this side also. But what do I add here to complete the square? Rule is divide this by 2. divide it by 2, and that's what you're going to put here, squared. Now, what is 3 squared? That's 9. I've got to add it to the other side. All right? Divide this by 2. That's 2 squared. 2 squared is 4. I've got to add that to this side. Now, what is this factored? It's x minus 3. X minus 3. This is y plus 2. Now, you can do it that way. Some people like it done that way. The way I personally do it is, instead of writing this as squared, I go ahead and write these numbers down. Dividing this by 2, I get 3. Squaring that's a 9. I add 9 to both sides. Dividing this by 2, I get 2. That squared is 4. I add that to both sides. Now I just come back and factor this. This is x minus 3 and x minus 3. So that's x minus 3 squared. This is y plus 2, y plus 2. And then this is 25. And so now I have, very simply done, the center is at plus 3 minus 2. Center is at plus 3. Come over here 3 units and down 2 units. And there's the center. The radius is 5. The radius is 5. So I will come up here. This is 2, so I'll come up here 3 more units, and that's 5. I will go over here 5, down 5, and over here 5, and I have the circle, where the center is at 3 minus 2 and a radius of 5. Now, that's all there is to this. Here's the key for you to learn, and that's what's called completing the square. You group the x's, complete the square. Group the y's, complete the square. And remember, whatever you add here and here, you got to add to the other side also. Then you come back, factor, concept, you have it. All right, let's look at example 5. Example 5, I'm going to group the x's. Then I'm going to group the y's. And I don't have any constants, so I'll just leave the 0 over here. Now, on this one, first factor the 3 out. That'll give us x squared plus 2x, and leave that space. And factoring the 3 out here, we'll have y squared minus 5/3 y. Now, the reason that I want to factor this 3 out is because I want the x squared by itself times 1, not any other coefficient. Let's go back and look at example 4. Looking at example 4, we want just x here, not 2x or 3x or something. We want just x minus or plus a number, and that's the center. If I get just x, and that's the center. Just y, and that's the center. All right, let's coming back now to example 5. Look at your notes there. We have now factored out the 3, and we have x squared plus 2x, and here we have the y squared minus 5/3 y. All right, complete the square. Dividing this by 2, we get 1. That squared is 1. Wait a minute. I'm really multiplying 3 times that. So I'm adding to both sides a 3, not just this 1, but 3 times this. So I've got to add a 3 to both sides. There's my 3 added there, and there's my 3 added there. Now, dividing this by 2 will be 5/6. Dividing it by 2 is 5/6. So adding that to both sides will be squared is 25/36. Okay, now wait a minute. No. 25/36 is what I'm adding inside here. That's times 3. So that's 25/12. And don't forget that. When you have this number out here in front, you want to add whatever you have to here, but it's then times that, and that's what you're adding to the other side also. All right, continuing this. This will then be 3 times x plus 1 squared plus 3 times y minus 5, 6 squared. And this is why some teachers and some students don't write this as 25, 36. They write it as 5, 6 in parentheses squared. Whatever you squared to put here is what you're going to get here. See, whatever this is divided by 2 is what's going to be here. Divide this by 2 and that's what's going to go here. Divide this by 2 and that's what's going to go here. However you want to catch that and see it and learn it, that's fine with me. Over here, getting a common denominator, 12 times 3 is 36 twelfths, plus 25 is 61 twelfths. All right, now we've got a problem here. We haven't been talking about a circle that had numbers out here in front. So what we'll do is to divide to get rid of these numbers. If I divide everything by 3, I get x plus 1 squared plus y minus 5, 6 squared is equal to 61 36. And now I have a circle whose center is at minus 1 plus 5, 6, whose radius is the square root of this. So the center is, graphing that, the center is at minus 1 plus 5, 6, a little less than 1, right in here, whose radius is the square root of 61 over 36, which is the square root of 61, 6. The square of 61 is a little less than 8, so it's about 8 divided by 6, just a little more than 1. So that radius is something like this. And so we have this circle, whose center, and you need to learn to write these down, center is minus 1, 5, 6, whose radius is the square root of 61 over 6. And then you graph it. Now basically, that is all there is to circles. It's just a matter of doing a lot of algebra, which is sometimes easy to foul up. You just be careful with it and follow through these examples. All right, now let's look at example 6. And this is the other type of, basically, the only other type of problem you have dealing with circles. Example 6 says this. You're going through the 3 points, 3, minus 1, 4, minus 2, and 1, 2. This circle goes through these 3 points. Minus 3, minus 1, 1, 2, 4, minus 2. All right, now, here's the next thing you need to learn. The general form of a circle is x squared plus y squared plus dx plus ey plus f is equal to 0. Now you go back and look at example 4 and 5 in your notes, and you notice that's what you have. You have x squared plus y squared minus 6x plus 4y is minus 12 is equal to 0. That's what example 4 was. You got, and on example 5, you got 3x squared, but you could divide everything by 3, and then you'd have x squared plus y squared plus 2x minus 5/3 y equals to 0. This is the general form of a circle. The general form of a circle. X squared plus y squared plus something x plus something y plus a constant or minus a constant equals 0. Now, looking at the figure again, this problem says that that circle goes through those points. Now, let's go back and remember the definition of a circle. The definition of a circle said x minus h squared plus y minus k squared is equal to something squared. What was the h and k? That's the center. What's the x and y? The x and y are these points out here on the circle. That tells us then that that's the x and that's the y. So, looking at the equation, that's the x and that's the y. That's the x and that's the y. So we will plug in. For the point 3, 1, we will plug in 3 everywhere x is. We will plug in minus 1 everywhere the y is. And then we get 9 plus 1 plus 3d minus 1e plus f is equal to 0. And there it is. We get the equation 9 plus 1 plus 3d minus e plus f equals 0. Okay, you put the 9 and 1 together, that's 10, move it across the other side, and you now have what's on your notes. 3d minus e plus f is equal to minus 10. Okay, let's go back and look at the general form again. Here's the general form, and it goes through the point 4 minus 2. So I put a 4 everywhere x is. I put a minus 2 everywhere y is. And I come up with 16 plus 4 plus 4d minus 2e plus f. I get 16 plus 4 plus 4d minus 2e plus f is equal to 0. Adding this together, that's a plus 20, moving across the other side, get a minus 20, just like your notes have. All right, looking back at the general equation again. Here we have the general equation, and it's going through the point 1, 2. I put a 1 everywhere x is, put a 2 everywhere y is. And that gives me 1 squared plus 2 squared, that's 1 plus 4, 1d plus 2e plus f. And I have the 1 plus the 4, d plus 2e plus f. Moving this across, I get a minus 5, and now you have 3 equations with 3 unknowns. Solve. Now, however you want, if you want to use determinants, do so. If you want to, the easiest way on this is just to subtract this one from this one. Subtracting this one from this, we get a minus d plus e is equal to 10. Okay. Now subtracting this one from this one, we get 3d minus 4e is equal to minus 15. And you have now 2 equations with 2 unknowns. Solve for d and e. Okay. Solving that, you get d equals minus 1, e equals 3, and f equals a minus 10. Now, if you don't know how to do that, then you need to go check out tape on systems of equations, 3rd order. Find out how to do that, or come by and see the instructor. All right, now we've got d is a minus 1, e is 3, and f is a minus 10. Let's go back to the general equation and plug that in. Okay, here we are, back to the general equation. So plugging in the d, which is a minus 1, that gives us x squared plus y squared minus x, put a minus 1 where the d is. E is 3, put a 3 here, that'll be 3y. F is a minus 10, put a minus 10 here, equals 0. And now we're back to example 5. Just complete the square. So this would be x squared minus x, leave a space, plus y squared plus 3y, leave a space, equals to 10. Moving this across the other side. Now, dividing this by 2, we get 1/2. Adding that to both sides is 1/4. Have to add that to 1/4 to both sides. Dividing this by 2, we get 3/2. Squared is 9/4. And adding that to both sides, we get 9/4. This then is x minus 1/2, parenthesis squared, plus y plus 3/2, parenthesis squared, is equal to 50 fourths. 50 fourths. So our circle is a circle whose center is at 1/2 minus 3/2, whose radius is the square root of 50 over 2. Okay, looking at example 7, we have another problem we have to deal with. Let's graph that, if possible. Okay. So this would be x squared plus 2x, leave a space, plus y squared plus 10y, leave a space, equals minus 26. Dividing this by 2 is 1. Squaring that is 1. I add 1 to both sides. Dividing this by 2, that's 5. Squaring that, adding to both sides, is 25. And so I have x plus 1 squared, y plus 5 squared is equal to 0. Well, center is at minus 1, minus 5. The radius is 0, therefore it is a point circle. A point circle. Now this is what's called a degenerate case of a circle. A degenerate case of a circle. Still works, the same process. Center is here and here. The radius is the square root of that. The square root of 0 is 0, so it is a point circle. All right, let's look at example 8. Grouping this, leaving a space, moving the 10 across is minus 10. Dividing that by 2 is 3/2, squaring that is 9/4. Got to add 9/4. Dividing that by 2 is 3/2, squaring that is 9/4. Got to add 9/4. Over here then we have x minus 3/2 squared is equal to plus y plus 3/2 squared is equal to minus 22, I think, fourths. This would be a minus 40 fourths plus 18, which would be 22, a minus 22 fourths. Center is at 3/2, minus 3/2. The radius is not possible. You cannot take the square root of a minus number. This is a degenerate case of a circle. It is no circle. You don't know that until you get down to here. Now, what I want to warn you about is example 7 and 8. Here you have the possibilities. When you go through this, if somebody just gives you a bunch of x squares, y squares, and x's and y's, and you go through this completing the square, you've got 3 things possible. Number 1 is this might be a minus a number over here. If it is, go check your work. You possibly made a mistake. Or it could be equal to 0, or it could be equal to any positive number, and you're all right. Whatever positive number is there, you take the square root of it, and that's the radius. So there's no difficulty there. So here are the 3, if you go back to example 6, and then this one, example 7, and this one, 8. Here are the 3 things that are possible when you go through completing the square. All right, let's look at another example. Example 9 says this. We want to come up with the equation of the circle that's tangent to that line. Well, let's see. Put that line down. If y is 0, x is a minus 1/2. If x is 0, y is equal to 1. So that's that line like this. All right. The center, well, we don't know the center. It goes through the point 2, 5. The circle goes through the point 2, 5. So we're going to have here 2. And let's see, if x is 2, y is 5. That's this point right here. Okay. And the center of that circle is on the line x plus y equals 9. So that says that x is equal to 9, y is equal to 0, and so we have this line right here. Now what we want is the circle that's passing through the point 2, 5, that's tangent to the line 2x minus y plus 1 is equal to 0, and whose center is on the line x plus y equals 9. The center is somewhere on this line, x plus y equals 9. Now this looks like a difficult problem. Well, to be able to write the equation of the line, we need to know the radius and the center. Well, let's see. The radius would be the distance from here to here. But we don't know what this center is. This center is just going to be xy, some unknown x and some unknown y. Well, let's see. What if we knew the equation of this line and the equation of this line? We could solve them simultaneous and find where they intersect. And when we do that, we've got the center, we've got our problem. Because once we find the center, once we find what this x and this y is, we got the center, and we can then find the distance from here to 2, 5 and with the distance formula, and we got the radius. So what let's do then is write the equation of this line. We've got this line. It's x plus y equals 9. Let's find the equation of this line. Find the equation of a line. Go back to the other tape, other chapter that you worked on. Equation of lines. Y minus y1 is equal to slope x minus x1. All right? Now, the point we have is 2, 5. The point 2, 5. We get to put 2, 5 here, going through that point. What's the slope? Hey, the slope, since it's perpendicular, is the negative reciprocal of this slope. What's the slope of this line? Minus a over b. The slope of a line is this coefficient of x over this coefficient of y and a minus that. So this would be 2 over minus 1. That's a minus 2. Change the sign, be a plus 2. So the slope, I'm sorry, wait a minute. The slope of this line is a plus 2. The slope of this line, which makes the slope of this a minus 1/2. A minus 1/2. All right, then multiplying across, this will be 2y minus 10 is equal to minus x plus 2. Multiplying 2 here will be 2y minus 10. Minus 1 times x is minus x. Minus 1 times a minus 2 is a plus 2. All right, moving the x across, we have x plus 2y is equal to 12. Now that's the equation of this line. Now I'm going to solve it simultaneously with the equation of this line. And that's x plus y is equal to 9. Solving those simultaneously, I'll just subtract this equation from this equation. It leaves me y is equal to 3. And if y is equal to 3, x is equal to 6. So, hey, we've got it. We've got the center is at 6, 3. So that tells us x minus 6 squared, y minus 3 squared is equal to. Now we've got to go find radius. Let's go back and look at our figure. If this is 6, 3, the distance from here to here is the square root of x minus x squared plus y minus y squared. So looking right over here, that would be the square root of 6 minus 2 is 4 squared. 3 minus 5 is 2 squared. That's negative, but it doesn't make any difference since we're positive, squaring it. And so this ends up being 16 plus 4, square root of 20. So coming back over here, our radius then is the square root of 20 squared. So our equation is x minus 6 squared plus y minus 3 squared is equal to 20. Let's look at one other concept about circles, and that is what's called a family of circles. This is the same concept as the tape before we did. If you looked at tapes or in your course you took on about the straight lines, you had a section called family of straight lines. The concept of having many lines going through a point or many different lines with a specific condition. we're going to do the same thing about circles. Let's say then we have the circle x squared plus y squared minus 6x plus 2y plus 5 equals 0, and the circle x squared plus y squared minus 12x minus 2y plus 29 equals 0. Let's find the family of circles that intersect with these. All right, now let's look at that graphically. What that says graphically then is we have something like this. The first circle up there would be, let's say, a circle something like this. The second circle would be a circle something like this, with the center up here. Now, another circle would be one coming through these 2 points of intersection. And another circle anywhere in here, one coming like this. What we're looking for then is the family of all the circles that are intersecting in those 2 particular points. Well, we use the same process as we did before. What we say is we use this equation plus k times the other equation equals 0. Now, just briefly, I didn't discuss this before, but briefly the understanding of this simply means this. If these 2 lines intersect, then they have points in common, which means I could multiply this one by some constant and add them, and they would be equal to 0 if they intersect. So this is the idea here then, is that we put a k can make this different points where they intersect in common points. All right, the math then is then k times x squared, k times y squared, k times minus 12x, and so on, 12 times, k times every one here. And we have then this. Then we group the x squares. That would be 1 plus kx squared. Grouping the y squares, that would be 1 plus ky squared. Grouping the x's, that would be a minus 6 and a minus 12kx. Grouping the y's would be 2 and a minus 2ky. And grouping the constants, we have plus 5 plus 29k. And this then represents a circle, x squared plus y squared, x, y's, and a constant. It represents all the circles that pass through the intersection of these 2 circles. Well, our example asks one other condition. It says, and which one of these many circles is it that passes through the point 0, 7? Which one right over here that passes through these 2 points of intersection and goes through the 0, 7 point? We want to find this particular one right here. The one particular circle that goes through these points of intersection of all these families of circles and it passes through 0, 7. Well, again, looking back, 0, 7 is the x, y point on the circle. So I will let x be 0, and I will let y be 7. So right down here, I will put 0 where x is. That would be 0. I will put 7 where y is. That would be 1 plus k equal times 49. 0 for x, that wipes that out. 7 here, that would be 2 minus 2k and a 7. Then this would be left 5 plus 29k. All right, what I have then is 49 plus 49k plus 14 minus 14k plus 5 plus 29k. All right, now that works out to be what? Let's see. We have 14k and a plus 29. That's a plus 15. And a plus 49 would be a plus 64k equals. Now we have 49 and 19, which would be 68. Okay. So this would be a minus 68. So k then is equal to a minus 68 64ths, or 34, let's see, 17/16, wouldn't it? Okay. So this would be 17 minus 17/16. So K is a minus 17/16. Now we can take this minus 17/16, plug it in right here, and come up with the equation of this particular circle. And we'll have to complete the square. You can follow the arithmetic and the algebra in your notes. But what you do then is take this K, put it right here, multiply that out, add, or you can do it right here. In fact, this is the best place to put it, right here. Put the K right here, the K right here, the K here, here, and then work it out. Let me just show a couple of those steps. If I put the minus 17/16 here, 1 minus 17/16 is a minus 1/16 x squared. And this would be a minus 1/16 y squared. All right, minus 17/16 here would be 96 plus a minus 96 plus 2 times 96. No, I'm sorry. It'd be 12 times 17 over 16. All that's times x. Let's see, reducing this right quick, if we factored a 12 out of here, we would have a 12, and we'd have minus 6. So we'd have a plus 11. So we'd have 132/16x. All right, plus, subtracting here, we would have 2 plus 34/16. So that would be 32/66 y, plus here we'd have 5 plus 29 times 17/16. 5, let's see, it's a minus. This would be 5 times 16 would be 80. Minus 17 times 29, 16ths. All right, let's see. We'd have to multiply this out. That would be 540 minus 17 would be 523. Okay, so this would be a minus 523/16. Now, multiplying everything through by 16, we have 66y, 132x, and that was a positive. And multiplying here, we have a negative 1 and a negative 1. Now multiplying everything through by minus, and we have a circle, x squared plus y squared minus 132x minus 66y plus 523. Move this across, complete the square, and you can follow the arithmetic through, and you have then that particular circle. This then is the concept about families of circles, the idea of working the problems. This then concludes the tape on circles.